So here we're still working on question 11 of this handout that starts way at the beginning, slopes and lines, and we've been working our way through. Right now we've gotten to question 11, which comes right after question 10 in an interesting turn of events. Now question 11, we just did most of question 11 in another video, but we've gotten to the point, the exciting point in question 11, you might say the climax, where after Part D came up with the answer that there is no intersection between the lines graphed in Part C and in Part A. We move on to a different kind of slope here. Graph the line having a slope of -3/2 and passing through the point -4 and 3. I'm going to change my colors up here just a little bit. Spring, what a lovely color name that is. Okay, so I know that if I want to graph a line that has a slope of -3/2 and passes through the point -4 and 3, I can just start by going straight to -4 and 3, right? -4 plus 3, that's this point right here. And now if I have a slope of -3/2, I can say the rise is -3 and the run is 2. So the rise of -3, let's see, that means going down 3, and a run of 2. I can put a point there. Rise of -3, run of 2. Rise of -3, run of 2. Rise of -3, run of 2, right? I don't have to put all these dots on here, but every dot that I put in makes it easier to line up my ruler to make sure that I'm going to have a line that goes right where I want it to go. So I've got all these points here, and then I draw a nice line that goes through all of them and keeps going right to the edge of the graph. So that was part E. I've got the line I was looking for. And then part F says determine the point where the line from part E intersects the line from part A. So the line from part A was this one on the bottom here. And I see actually that it goes right through 0 and -3. So let me put a little point on there, and we'll call this color strawberry, I guess. I'm going to put a little notch here, and I've determined that they intersect right at this spot. The point where they intersect is at 0, -3. I can spot that just from looking at the graph. Okay. Now, if I want to make sure that that's accurate, right, one thing I can do is I can check and see, well, 0 and -3 was in the table of values. I know that does work for this line from part A. But I could also say, well, when I was at -4 and 3 over here, -4 and 3, does it make sense that I would go exactly through 0 and -3? Right? I know that every time I was going down 3 and over 2, down 3 and over 2, yeah, it makes sense that I'd hit that line as well. So this answer is pretty satisfying. Next question says, graph the line having a slope of -3/2 and passing through 3 and -6. So again, what I can do here is I can go to 3 and -6, that's 3 and -6 down here, and I want a slope of -3/2. So I can either say that's down 3 and over 2 like that, or I could also think of it as up 3 and -2 on the run, right? That's, again, the same slope as -3/2. I can do +3 over -2. +3 and -2. Rise 3, run backwards 2. Rise 3 and run backwards 2. And again, I get out my ruler and I make sure to line it up as well as I can so that I get a nice juicy strawberry color. And if I do this perfectly right, what you might notice on your graph is that you should, better than me actually, you should get a perfect square right in the middle there. And you'll also notice, you see the strawberry and the green one here, they're never going to intersect. Think back to a couple of questions ago, why would they never intersect? Well, this one's got a slope of -3/2. This one's got a slope of -3/2. If they have the same slope, they're never going to meet. Something else you might notice, if I were to get out a protractor and measure here, this angle here would be exactly 90 degrees. And there's a reason why it would be 90 degrees. Remember, what was the slope of these two lines here that are parallel? The slope was 2/3. The slope was 2/3 here. Now, you won't get tested on this, but you'll see later on in later grades that if you want another line to come in and hit it at 90 degrees like this, then you take the slope of the first line, you flip it over, so instead of having 2/3, you have 3/2, and you make it negative. So the slope here, -3/2, you see that? and 2/3, negative 3 over 2 versus 2/3. This is what we call the negative reciprocal. It's negative and it's a flipped over version of that. And then together you get a nice 90-degree angle there.